Hi, thank you for joining us with this SD-WAN Nebula orchestrator introduction. So I guess we should start with what is SD-WAN in the first place, before we even talk about kind of its benefits. So SD-WAN stands for Software Defined Wide Area Network, and essentially it allows us to centrally manage the WAN side of all our connectivity and allows us to create a global policies over all of the infrastructure to ease the deployment. Many enterprises have kind of looked at this already in the past and used it to simplify and create a more faster and more reliable approach to traditional methods, which they would use like an MPLS or a tier 1 ISP. They've also used it to reduce overheads, which are often associated with that type of delivery as well. Whilst SD-WAN is widely recognized in enterprise today, we feel that the SMB market really needs to try and adopt this type of technology, and we've brought this type of technology into this marketplace to try and help with the traditional deployments where we can see vast improvements in reliability performance over traditional VPN networks, i.e. site-to-site connectivity, as well as being able to manage multiple sites or multiple customers under the same platform. As we go into this presentation, we'll start to sort of talk around some of the complications and some of the problems that we see from both sides, whether it be the customer or whether it be the actual value-added reseller or the MSPs, the managed service providers, who are looking for network diversity, improvements in connectivity, simplified approach to delivery, and even management on a scale, whether it be for smaller customers or whether it be for lots and lots of different customers. So let's start by looking at some of the challenges that traditional site-to-site networks have, and looking at the challenges from a point of view of the actual end users, the SMBs themselves. So not the actual installers or the IT company or the managed service provider, but the actual requirements of a client and the challenges that they are kind of having to tackle. So first, they have a greater reliance on cloud, whether it be Office 365, or whether they're carrying their own data infrastructure in AWS, or whether they're using things like Dropbox. These are all cloud technologies, and the internet connectivity itself needs to be reliable, and the customer has a reliance on that to gain access to it. So obviously much more reliance on the internet itself, as well as the reliability of the internet itself. So when we talk reliability, we're not just talking about on or off, we're talking about low latency. Latency has a larger impact on applications, especially voice or video. So if we have a high latency, then it means that things like voice and video will start to jutter, break up, and the video, for example, will go pixely, drop out, and even, lose connectivity. I mean, we've all seen the time when you've been on the internet and it's a little box will come up on Skype, for example, and, it will say, poor connectivity, and then all of a sudden it'll start going bitty and dropping out and losing some of the video quality. So, people don't want this type of experience. They want it to be seamless and operate at its high efficiency. We also have faster connectivity is a big challenge for SMB. So, fast LAN today, as in we've got 1 gig and even 10 gig LANs. Even in SMBs, this is quite common. But we have extremely slow WAN connectivity, i.e. internet connectivity. Often the end users are looking for increase in security. There's much more awareness of the challenges in security in today's environments, especially with the crypto lockers and things like that. So SMBs, they have the challenge of maintaining this on their networks, but don't necessarily have the expertise to do that. They obviously need scalability. The workforce is no longer just in individual offices. Often they're dotted about. They could be small offices with 2 or 3 people in, but it seems to be that that trend has changed from one big office to lots of individuals, or even people working from home where they need to dial in. So we still need to try and keep that scalability and connectivity for those as well. Obviously, it goes without saying that our customers, when they're looking at these challenges, they're also trying to look at how they can do it within a budget. whether it be for installation or ongoing costs for the connectivity itself. So let's look at the challenges for the value-added resellers or the managed service providers. And although they have some similarities to the actual end customer, when they're delivering these services, they obviously, they come across the actual technical elements that really defines what they can and can't deliver. So first and foremost, they need to try and maximize on what the connectivity is available, i.e., if they go to a rural area, what kind of connectivity can they actually get to deliver to their services to this site, or even when they're in industrial estates, sometimes the connectivity itself is also not that great, so they have to look at what's available and try and maximize on that. They need easier control over the deployment and management. Often, if you're looking at site-to-site VPNs, traditionally it's static devices installed at each location. You have to dial into each one, configure each one independently. Maybe you have a bit of software that can centrally monitor them so that you could be a bit more proactive if something goes wrong. But the reality is that the control and flexibility building this is much more complicated, especially if you're going to scale out. Often we need to reduce the complexity, so not just the fact that you're going to install lots of them, but especially as you scale out, some of the challenges are allowing the traffic to pass between all these devices, especially in a hub and spoke environment where you have a single device in the center and you have lots of sites or satellite sites connected into the central core. It means that the routing between these sites, when traffic wants to go from one site to another site via the hub, become extremely complicated and also very difficult to diagnose if something goes wrong. They can be very time consuming to find issues, especially in the routing tables. Remote bottlenecks. So when we talked about this hub and spoke environment, we need to remove the bottlenecks in an environment. For example, passing traffic through a central core can be extremely complex, but actually connecting all these sites together can be complicated as well, as we will demonstrate a bit further into this presentation. And clients, they just want the network to work. So to remove the bottlenecks, you need to improve the way that these types of sites operate. So additionally, we need to simplify network diversity. It kind of ties in with the first point where we need to maximize on what's available. But at the same time, there could be, different types of internet service providers at each location that you want to kind of utilize to create, reliability or failover in these environments. And often if you're looking for connecting sites together, it can be more complicated by using different providers. And the idea is that if you want to create a layer over the top of it, while it can be done with traditional site-to-site networks, it's not as straightforward to manage or maintain and not as seamless as we would like it to be. And with SD-WAN, we try to address this kind of challenge, which we will go into a little bit further into the presentation. Additionally, value-added resellers and MSPs who are managing networks for their clients, they want to improve the user experience. For those of you who have delivered site-to-site VPNs or have site-to-site VPNs today, you will be aware of the fact that there isn't a great deal of control of what goes down a VPN. So it makes it incredibly difficult to tailor the traffic for the business applications for each individual customer. Although there are some controls, it becomes incredibly difficult, especially if you want to do it across the board on a larger scale where you have lots of different sites talking to each other. So let's start by looking at a traditional site-to-site VPN and how they kind of operate today. So in order to build a site-to-site VPN, i.e. a connectivity between two sites, a tunnel that allows you to securely pass traffic between these two sites, you basically put two devices in each site, a firewall, for example, and you build a VPN tunnel, IPsec tunnel between these two places. There are only very simple connectivity checks to see whether this is actually up or down. And this basically is controlled by either doing a ping, like bouncing a message off the other device, or whether the physical port is down to say whether the connection is alive or whether it's dead. There is actually no test to check the quality of the line, whether it's degraded, whether it's losing packets, etc. Although you could use the ping. Many devices just have a yes, it's replied, or no, it's not replied. It's extremely difficult to manage the traffic that goes between these, especially if you want to push it via a firewall to start blocking traffic. This becomes extremely complex and very difficult to manage. And that basically that means that you can't really traffic shape or manage any complexity to create this user experience we've just talked about a minute ago. As we start to add more and more sites to our infrastructure, so in our example we have 2 offices in the UK and we have 1 in Denmark, and as we want to pass traffic between site 2 to site 1, we have to go via the hub, which is essentially our Denmark office. This creates a routing rule that's required to say when site 2 requires to go to site 1, it needs to go via the Denmark office, and vice versa. For traffic to come back from it, it needs to go backwards. So we start to build up these rules to go via a hub. And whilst this is acceptable on a small scale, the problem is as the sites scale out, it becomes incredibly difficult, and also additionally creates this choke point in the central network. So at this point we have very complex routing that has to tell every single site where each one is. So imagine every time you had to go through the door, you'd have to ask somebody for where the next door is, and the next door, and the next door. We'd have to create a routing rule manually at each one of these points in a traditional site-to-site VPN network. Additionally, like we said before, this choke point where all the traffic is actually centrally coming through Denmark means that we have to have a large firewall and a large amount of bandwidth at this central point to carry all the traffic to each site. To combat this in traditional deployments, many people decide to create IPsec tunnels between every individual site. I mean, I know that certainly I've done this in the past when I've had to compensate for problems like this. To remove this choke point, I essentially build a VPN between every site, meaning that I have to then build routing rules to allow each site to communicate with each other individually. This becomes incredibly complex, especially if you are scaling out. I mean, it's not so bad for 2 or 3 sites, but or even that becomes quite complicated and becomes a lot of routes. You know, essentially every single point we need to know where every single point is and how to get there. This is further complicated when we start to add additional lines. For example, let's say we create a primary and secondary line, so we have 2 internet lines for each site. We then additionally have to create a routing rule that says if you go down this line first, if this line doesn't work, then you fail over to this one. This again creates an enormous amount of complexity, and what I'm trying to demonstrate here is we are getting an increase in complexity in deployment. It becomes incredibly difficult to manage afterwards, and as you want to scale out, it becomes almost impossible to remember where everything is meant to go. This problem is further complicated by the fact that, again, as we go back to the beginning, we have no way to manage or monitor this line's quality. So if this line degrades, i.e. it's losing packets, it's not reliable, the typical connectivity checks in most devices are, like we said before, up or down. And if packets of data start to get lost, then the quality of the line is bad, but the line is still actually functioning. So that means that the experience for the end user is that actually it's not very good quality, and things like phone calls and videos will become extremely choppy and will begin to start buffering. And reality is we want to try and automate that process so that if there is poor quality, that it picks a better line to operate in. So how do we combat a lot of these problems that we've kind of just discussed? So SD-WAN kind of introduces a bunch of tools or a consolidation of functionality that we've kind of put together to try and combat all the challenges that are traditionally given to us in site-to-site VPNs, and try and ease the process of deployment, management, and even scalability. So first off, obviously we have this zero-touch provisioning called ZTP, which allows us to deploy SD-WAN devices to site very quickly and very easily to minimize operational time and expense in the deployment phase. We have functionality that we have designed to do real-time monitor of path quality, so dynamic path selection, which enables it to basically pick the best quality line and transmit down that line. This obviously combats the problems that we've just been discussing about the fact that you can't monitor a line for quality, only whether it's up or down. WAN optimization means that because we're controlling both WAN points, we can actually improve the quality of connectivity between them, or the way that we actually transmit data between these, because we're managing both points. We have content filtering, so it allows us to do content filtering on the HTTP and HTTPS traffic, as well as be able to identify applications through our application intelligence, which can then in turn be used to prioritize applications and their behavior over the connectivity itself. We also talked about the fact that to build a very complicated network to avoid this bottleneck process, we would have to essentially build site-to-site VPNs everywhere. So by using dynamic mesh VPN technology, it allows us to dynamically build and create routing tables on the fly to allow this site-to-site connectivity to take place, but without the complexity of writing lots and lots of rules, and allow the system to do this dynamically when it's required, and also seamlessly, so that the customer or the end user is unaware that this is taking place in the background. So to demonstrate some of those challenges and how the features actually work, we have some diagrams to give you a visual aid to understand how they work and how they operate. So to start with, we'll look at application intelligence and WAN optimization and see how that can help. Because we're controlling both sides of the connection, we can optimize the TCP packet itself, maximize the efficiency of the data transmission itself as well, along with looking at the latency and the packet loss to help mitigate any issues. When we combine these protocols or optimizations with the fact that we can prioritize the bandwidth according to application in real time, it means that we become super efficient at how we can transmit data across these 2 points. So when we're using SD-WAN, we can improve the speed, the efficiency of the connectivity versus a traditional IPsec VPN. At the beginning, we discussed about the fact that, we want to measure the connectivity rather than just check whether it's up or down, because this obviously gives us problems, especially when a line is degraded. So dynamic path selection gives us the ability to monitor and manage the connection and in real time move traffic around without the user being aware, so that it is always on the optimal best condition line. For example, you're transferring voice calls, then you want to make sure that you are on a good quality line. So if a line degrades, we want the ability to be able to move seamlessly across to another line without the user being aware of this taking place. DPS enables us to do that by moving the traffic around. So when it detects the line is degraded, it simply moves the traffic to the other line, and then when the line is not degraded or is better quality, it will move it back. You could even simulate this by actually pulling the cables out of the front of the device. It would seamlessly work for the customer. They would be unaware that they are being, lines are being disconnected and reconnected. The traffic for them and their user experience for them would maintain the same or even better, because it would be obviously looking at the best path for the connection itself. In a traditional approach like site-to-site VPNs, where maybe a site has gone down or the line is degraded, you obviously have to write in a bunch of rules into the firewall to say, okay, this line is the failure, this is the primary. And while this can be achieved, it can't be achieved as seamless as you could do if you was doing it with this type of delivery method. This essentially gives you always on connectivity, high availability for your client all the time with the best quality line. There's no manual process of switching lines, etc. It's a more proactive approach to delivering good, high quality connectivity between sites. Earlier on in the presentation, we also mentioned about the bottlenecking in a network when using hub and spoke. Hub and spoke is the traditional method of delivering site-to-site connectivity. It makes a lot of sense, given that in the complex way of deploying site-to-site VPNs, this is probably the easiest approach to deliver in traditional site-to-site VPN networks. The problem that we discussed earlier was when you want to start to avoid the bottleneck in this environment and start to build out a web of connectivity between these devices, creating IP sectors between every single one and creating all the rules manually. This becomes extremely complex, as we discussed before, and to avoid that and to make this simpler, we can use a method called dynamic mesh VPN. This basically allows us to dynamically create a site-to-site connection between two sites when information is required to pass between them. Again, just like the dynamic path selection, we are able to generate a connection between the two sites which is optimized. So rather than sending it via the hub, and when we know that we've got two sites together, we can build a site-to-site connection dynamically, offload the traffic without the user being aware that it's taking place, to make the latency as low as possible. When this is completed, this connection, we can then stop the connection and revert back to the traditional method. This means that we're always creating the best path, including generating a mesh style delivery on the fly for our customers, so that when we begin to transfer the data between the two sites, is at its optimum. Earlier on, we discussed about SD-WAN and its optimization technology, so optimizing TCP acceleration and maximizing the efficiency of the internet data transmission itself. So it sounds very technical, but in reality, this basically means that we can improve the efficiency of transmitting the data between the 2 points and increasing the throughput and giving much better results. So to demonstrate this, rather than talking about lab tests, etc., we basically simulated a real live scenario where we connected 2 of our sites together, so our headquarters, Taiwan, and our German office, and transferred using a typical protocol like FTP. So we transferred a 1.9 gig file between the 2 points several times and created an average transfer time of 2 hours 40 minutes. You can also see the rest of the connection statistics on the screen. So you can see the 300 kilobits per second, the loss rate that we're going, because this is quite a long connection between these 2 points. So then we turned on WAN optimization on the same device on the same connections and simulated the same transfer with the same file. This reduced the connection or the transfer time from 2 hours 40 to just 10 minutes. So a massive improvement in terms of transfer and increasing the transfer rate from 300 kilobytes per second to 24 megabits per second. So not only does it improve the speed, the quality, and also maintain a very easy way to deploy and expand, also gives us multi-tier management. So we're able to structure in a 3-level topology, so by group, organization, and site, allowing to create configurations and functions at each level to automate and simplify the management. As we discussed before, we can also gain control over the security itself. So we can apply rules at a global level across the board on all the sites for firewalls, Geo-Enforcer, which allows you to block by region, so you can block traffic from a specific country, as well as content filtering and application control, so awareness of the applications and their behaviors. To get started with SD-WAN, it's easy to simply switch from hardware that's already supported. So if you have a VPN device out there already, and we'll go into the supported models in a moment, then you can simply switch to SD-WAN and control it via our Nebula orchestrator platform. And for those who want peace of mind, they can switch back to being standalone at any point as well. Deploying SD-WAN is pretty straightforward. You can even do it by delivering by email, SMS, and USB, allowing a very seamless deployment or zero-touch deployment. You are able, for example, to push a USB stick into the front of the device, make sure it's plugged into the internet connection, turn the device on, and it will simply auto-deploy, even with the internet connectivity settings already predefined. Once the device is deployed, you'll be able to configure and manage all of the settings and all the functions directly from within the Nebula orchestrator platform, which is used to manage the SD-WAN devices centrally. As part of the initial configuration, or indeed if you are expanding your sites in your organization, you are able to pre-configure and define which branches need to connect to each other and in what manner, for example, if they're a hub or if they're a spoke. This means when you're doing the deployment, it means that when you add a new device, it simply deploys and adds all the site-to-site connectivity, including all the rules about how they get from point to point automatically and dynamically. And whilst this improves the efficiency and deployment of site-to-site connectivity, we still need to be able to connect clients. We're able to create a hassle-free way to deploy client VPNs by sending a link that the user can click on and auto deploy the VPNs on Mac, macOS and iOS. So this removes the frustration and the complication of walking a end user through setting up a VPN connection from their client device into your network infrastructure. SD-WAN is supported on the VPN 50, the VPN 100 and VPN 300. And to manage these devices under SD-WAN, you need to register them in Nebula Orchestrator, which is the platform allowing you to centrally manage the devices. And the VPN 50, 100 and 300 include 1 year of the full package for Nebula Orchestrator, SD-WAN and security services, which we've covered in today's presentation. We will go into what's included in a second. And really, depending on your specifications for your site, really dictates which product you kind of need to pick from the portfolio. But if you need assistance on looking at the portfolio and which product fits your scenario, you can contact a sales engineer from your local region who will be more than happy to help you and guide you through the selection process and how to deploy, or how best practices to deploy SD-WAN in your environment. As we mentioned before, when you register your VPN 50, 100 or 300 with Nebula Orchestrator, you automatically get 1 year included of the SD-WAN service and the security services, which means that you can take advantage of the dynamic path selection, the WAN optimization, the content filtering, the geo enforcer, as well as giving you access to a longer period of logs and storage of configuration settings within the platform. Once the 1 year that's included in the devices comes to an end, you have a choice to either renew that service or to drop down to the Nebula Orchestrator basic version, which allows you to still manage and maintain the devices centrally. So a replacement for managing site-to-site networks at a basic level, but you lose a lot of the benefits of SD-WAN. For example, dynamic path selection or WAN optimization, which we kind of demonstrated earlier in this presentation, on how it improves the throughput, how it improves the reliability for your client, and how the user experience is seamless so that they feel like they're getting an always-on connectivity, despite the fact that maybe things are going wrong in the background, like the line is degrading. Your customer is unaware this is taking place and gives you much more flexibility in terms of how you manage a fault for your customer. Also, it gives you scalability. So if you're trying to scale out and manage many more customers, then this type of technology can help you not only scale out, but also maintain a high quality of service. So thank you for taking the time to watch this presentation. Hopefully this has been informative and you understand the Nebula Orchestrator platform and SD-WAN and what this can do for you. For more information, you're obviously able to visit our website. Additionally, you can speak to one of our sales teams who will be more than happy to talk to you about the SD-WAN solution, or indeed set up a demonstration with one of our sales engineers who will be able to talk to you a bit more in depth about the technical deployment and how it would fit into your environment.